Project Management, Module 6, Lecture 2, Developing a Project Schedule. Learning objectives for this lecture are to calculate the early, late, and slack activity times, to understand the importance of managing the critical path, and distinguish free slack from total slack. The reading assignment is Larson, Chapter 6. So first of all, we figured out from the previous example, we were able to calculate the ES, EF, LF, LS time. Now we're going to work on the slack time. So first of all, there's two kinds of slack time. There's total slack and free slack. So let's first tackle total slack. So total slack tells us the amount of time that an activity can be delayed and not delay the project. So that's very important. It's also how long an activity can exceed its early finish date without affecting the project end date or imposed completion date. And it's simply the difference between LS and ES or between LF and EF. So you can calculate either way. LS minus ES or LF minus EF. So let's do this for this current one. So here we started with the, so now we're going to do the total slack. So we'll start with this first one here. 85 minus 85 is 0. Notice also 100 minus 100 is 0. So we're figuring out the total slack. Ignore the FS for a second. That's the free slack, and we'll talk about that in the next slide. But for now, we're going to kind of work our way backward and calculate the TS values. So moving on to G, activity G, 15 minus 35 is 15. 30 minus 15 is 15. 20 minus 10 is 15. And finally, 0 minus 0, 0. Thus, we could also use the LF minus EF time. We got the same value for the TS values. So that's the top path. We go through the middle path. You can calculate them exactly the same way. And through the bottom path, same kind of way. So the free slack is different from total slack. Free slack is the amount of time an activity can be delayed without delaying an immediately following activity. It's also defined as how long an activity can exceed its early finish date without affecting the early start date of any successors. So what free slack does is allows flexibility in scheduling for sources. So the key thing here with free slack is it only occurs at the end of the chain of activities where you have a merge activity. So that's critical. Watch out for those merge activities to get the free slack. So let's look at our example here. So here, we calculated the forward path, we calculated the backward path, we got the times here, 70, 85, and 50, right? So let's see why this is important here. So here, the reason this is important because let's look at G here. So activity G is the last activity in the upper path. So this has a free slack of 15. So how do you get to 15? How do you get to 15? Well, it's the middle path is 85. The top path is 70. The bottom path is 50. So here, 85 minus 70, that gets the free slack to be 15 here. For this one, notice it's this one's 0 because it's 85 minus 85, which is 0. For the bottom one, it's 85 minus 50, so that's 35 goes here, right? And then you can, for the rest of these, it only occurs at this merge this merge activity, right? These other ones, D, B, A, C, and all have the free slacks of 0. So why is this important? So here, again, the free slack to the upper path is 15. Well, what that means is that we can delay activity G up to 15 days, without any consequences. It doesn't require coordination of any other managers to do that because, that's what the free slack means. On the other hand, if either activity B or D, which have zero free slack, is delayed, if either one of those are delayed, the managers of those particular activities need to notify, G here, that, hey, there's been a problem, so they can adjust their start schedules, right? Because there's no free slack here. So if this guy runs into a problem, he needs to notify this guy and that guy that he's going to go over by a few days. Same thing with this guy. He needs to notify this guy that, hey, he's going to be over a few days. So here, let's look at it. The book works out an example. It says, okay, suppose activity B is delayed 5 days. Well, then this manager should notify activity D and G that their slack has been reduced by that amount, right? So you have to take those things into account. So in this example, activity D can't start then until day 20 because if you delay 5 days here, then that pushes this one to 15 to 20. And it also reduces the D slack activity to 10 days. If the 15 here is 20, then 30 minus 20 is 10, right? So that would change the bottom numbers here as well. And then also that affects activity G. Their free slack is also reduced to 10 days, and so it kind of a delay here kind of delays this one and delays that one because there's no free slack. So here, activity F here, going through this, activity F is the last activity in the lower path. It has a free slack of 35 days, while activities B and D do not. They don't have any free slack at all. So here, that this activity doesn't need any coordination with any other activities unless it has a delay that exceeds the 35 days, the free slack 35 days here. So if it exceeds it by 20 days, if this is delayed 20 days, it's not going to affect anything. So, there's a huge difference between the free versus total slack. At first glance, it seems trivial, but it's really important. Because when you're responsible for a late activity that has zero free slack, you impact the schedules of subsequent activities. And you should notify the managers of those activities in that chain that you will be late. Again, note that total slack is shared across the whole path. Alternatively, if you're responsible for an activity that has free slack when you start, you don't need to worry about notifying anybody as long as your work does not absorb all of the slack. So here, the critical path is, how do we compute that? We talked about it earlier. It's the longest path through the activity network. So here, obviously the critical path is the middle path. It's 85 days. So it's marked by the dashed lines. So activities A, C, E, and H, that's the critical path. And it's really important be able to identify the critical path because it impacts the completion time. So on the critical path, that's the one you want to sort of concentrate on and put your best people on. It's where you pay extra attention when doing your risk assessment. It's where you don't look when other managers are asking to borrow people or equipment, right? So if these guys in this upper path want to borrow some people, you don't want to give them from guys working in this path. You want to maybe give them to some guys working on Project F here, move some of those guys up. And so that's where you want to concentrate on, again, is that critical path. So oftentimes in developing these networks, people talk about what's called sensitivity. And this is, sensitivity is defined as the likelihood that the critical path will change once the project is initiated. So that a network that only has one critical path and non-critical activities, those will be called insensitive. And paths that have very complicated critical paths would be a very sensitive project. Okay, this is the end of this lecture. I'll see you in the next lecture.